GCE O Level Mathematics Lecture 20 Simultaneous Equations. Hello everyone, Dennis here. Here are a few learning objectives that we want to achieve at the end of the lecture. First, we want to learn how to draw linear graphs, followed by understand the idea of simultaneous equations and their solutions. After that, we want to solve simultaneous equations using three methods. The first method is graphical method, the second method is substitution method, and the third method is elimination method. After that, we want to apply simultaneous equations in two variables to solve word problems. Let's learn linear equations in two variables. A linear function is in the form of y equals mx plus c, where m and c are constants and x and y are variables. If you have learned coordinates geometry chapter, you will know what is the meaning of m and c, where m is the gradient of the graph and c is the y-intercept. So here's an example. Y equals 2x plus 3. So this is a linear function, and when x equals to 1, then y will be 2 times 1 plus 3. So this is where we substitute the x equals to 1 into the equation. Then we calculate the value, so y is equals to 5. Now, if we can change the x value to 2, then the y value will change as well. So to calculate the y value, you just substitute x equals to 2 into the function. It becomes 2 times 2 plus 3, and the value is 7. Alright, so we can continue to change the value of x, but to make it simple, we can tabulate it into a table where this is the x and this is the y. So let's say x equals to 1, then y will be 5. X equals 2, then we calculate the y value to be 7. When x goes to 4, the y value becomes 11. When x goes to 5, the y value becomes 13. Alright, now we have all the values of x and y here. We can plot the graph, because this x and y will tell us the coordinates of the point. So let's draw it out here. So this is the Cartesian graph. We have the x-axis and we have the y-axis. So we have a scale for the x-axis for 1 cm is to 1 unit. So we have this 1, 2, 3, 4, 5. And for the y-axis, we put a scale of 1 cm to 5 units. So this is 5, then 10, and 15. So the first point is 1, 5. So this is the location of the point 1, 5. Followed by the second point, 2, 7. The third point, 4, 11. And the fourth point, 5, 13. Then we can take a ruler, join these points with a straight line. So this is the graph of y equals 2x plus 3. As you can see here, each pair of values of x and y are the solution of the equation as they satisfy the equation. Example, when x is 1 and y is equals 5, they are the solution of the equation. However, when x equals 1 and y equals 6, they are not the solution of the equation. All the points that lie on the straight line are the solutions of the equation. So now let's look at this point. This point is when x is 3, y is 9. The coordinates is 3, 9. So when x equals to 3, then y equals 2 times 3 plus 3, and the value is 9. Hence, x equals 3 and y equals to 9 are the solution of the equation. I hope you understand the meaning of solution here. Alright, after understanding how to draw linear graph and the concept of the solution of an equation, let's look at example 1. The price of a water bottle is X dollars and the price of a pencil case is Y dollars. 5 times the price of the water bottle is $40, more than twice the price of the pencil case. A. Form an equation connecting X and Y. B. Draw the graph of the equation in A. C. If 5p is the solution of the equation, find the value of p. So here is the solution. For A, to form the equation connecting x and y, we have to translate the information from the question into mathematical equation. So now the keyword 5 times the price of the water bottle, we can write it as 5x, where x is the price of the water bottle. Also, twice the price of the pencil case. So for this sentence, we can write it as 2y, where y is the price of the pencil case. And this sentence tells us that 5 times the price of the water bottle is $40, more than twice the price of the pencil case. So which means that the difference of these two quantities are equal to 40. Hence, 5x minus 2y equals 40. So this is the equation that we want to form in part A. For B, before we want to draw the graph of the equation in part A, so we have to make y the subject first, so that we can put the equation in the form of y equals to mx plus c. So from part A, we can say that 2y equals 40 minus 5x. Hence, y equals to negative 5 over 2 x plus 20. Alright, so the equation is in the form of y equals to mx plus c form already. Now, we can calculate the corresponding x and y values based on this equation. Let's put the value into the table. So this x and y. We choose some values for x. Let's say when x equals to 2, then y equals 15. When x equals to 4, y is 10. When x is 6, y is 5. And when x is 8, then y will be 0. So after that, we can start to draw this graph on the Cartesian plane. So this is the graph paper, this is the x-axis, and this is the y-axis. So for the x-axis, we put a scale of 1 cm is to 1 unit. So this is 1, 2, 3, 4, 5, 6, 7, and 8. For the y-axis, we put a scale of 1 cm to 5 units. So we have 5, 10, 15, 20, and now we can start to plot the graph. So the first point to 15, it is at this location, followed by the second point 4, 10, the third point 6, 5, and the fourth point 8, 0. We take a ruler, draw a straight line connecting all these points. And this straight line is the graph of 5x minus 2y equals 40. So for C, to find the value of p, so the coordinates 5p tells us that the x value is 5, and from the graph, the corresponding value of y is 7.5. Hence, from the graph, the value of p is 7.5. Now, let's try it yourself. Number 1. Ahmad works for X dollars per hour and Bruce works for Y dollars per hour. On a particular day, Ahmad works for 6 hours and Bruce works for 10 hours. Given that Bruce earns $50 more than Ahmad on that day, A. Form an equation connecting x and y. B. Draw the graph of the equation in part A. C. If 15b is a solution of the equation, find the value of p. You can pause the video and try to solve it yourself. So here's the solution. For A, to form the equation, let's read the question carefully. So Ahmad works for 6 hours. So from here, we can write as 6x, where x is the earning of Ahmad per hour. And Bruce works for 10 hours. So from here, we can write as 10y, where y is the earning per hour for Bruce. And given that Bruce earns $50 more than Ahmad, so which means that the difference of their earnings is $50. Then we can write the equation as 10y minus 6x equals 50. Hence, the next step we want to do is we divide by 2 for both sides to simplify the equation. We will get 5y minus 3x equals to 25. So this is the equation they want to form for part A. For B, to draw the graph of the equation in part A, we need to make y the subject first. So from the equation in part A, we can say that 5y equals 3x plus 25. Hence, y equals 3 over 5x plus 5. Then we build up the table here for the x and the y value. So let's choose x as 10. So when x is 10, then y will be 11. When x is 20, we calculate the value of y, we get 17. When x is 30, then the y value will be 23. When x is 40, and the y value will be 29. Alright, now we have the table here. We can start to plot the graph. So we have the Cartesian plane here, and this is the x-axis. This is the y-axis. We choose the scale for the x-axis. 2 cm is to 10 units. So this is 10, 20, 30, and 40. For the scale for the y-axis, we can choose 1 cm to 5 units. So 5, 10, 15, 20, and 25, 30. Right? So the first point is 11, 10. So this is the location of 10, 11. For the second point, 2017, the third point, 30, 23, and the fourth point, 40, 29. Then we take a ruler, draw a straight line, connecting all the points here, and this line is 5y minus 3x equals 25. Alright, then for part C, to find the value of b, let's look at the graph. When the value of b for y, the x value is 15, so the corresponding value of y will be 14. Hence, answer for C, from the graph, b equals to 14. Now, let's understand the concept of solving simultaneous equations in two variables. Consider these two linear equations. 2x plus 3y equals 11 and 3x minus 2y equals to negative 29. Each linear equation has infinite number of solutions because any point lies on this linear graph will be the solution of the equation. So there are infinite number of points lying on the straight line, hence we have infinite number of solutions. The process of finding the common solutions among these two equations is called solving simultaneous equation. Recall that in lecture 18, solving simple linear equations in one variable, as you can see the title of the lesson, it is a simple linear equation and one variable. If we have one variable, then we just need to have one linear equation we can solve the equation and get the value of the variable. However, in this part, as you can see from here, we have two variables. So if we have two variables, we can't solve it using only one linear equation. We need to have two linear equations. We solve it and we can get the value of x and the value of y for this case. Alright, remember, two variables, we need to have two linear equations. Alright, so when we solve the two equations, there are three possible results that we might get. The first possible result will be we'll get one common solution, which means that with one value of x and one value of y that satisfy both equations. And if we plot the graph of these two linear equations, so both linear graphs intersect at one point. So the second possible result that we may get is no solution. Why is it so? Because both linear graphs do not touch each other because they are parallel lines. The third possible result that we might get is infinite number of solutions, because when both linear graphs overlaps with each other, then we'll get infinite number of solutions. Both linear graphs are the same graph. So we'll discuss more on these possible results in the next slides, and you can see how it works when we look at the graph. As I mentioned in the learning objectives of the lecture, there are three methods to solve simultaneous equations. The first method is the graphical method, and the second method is the substitution method. The third method is the elimination method. So to discuss these three methods, we'll use the same three examples to solve using all these three methods. So example 1 will be one solution. Then these two are the linear equations: 2x plus 3y equals 18 and 4x minus 5y equals to -8. The second example, with no solution, we have the equation of 5x plus 4y equals 20 and 5x plus 4y equals to 32. The third example is infinite solutions. The first equation is 3x plus 4y equals 12, and second equation is 6x plus 8y equals to 24. Let's look at the next slides to discuss all these three possible solutions that we might get. Alright, so as I mentioned, the first method to solve simultaneous equation is graphical method. So let's look at example 1. Solve the simultaneous equations using graphical method. Right, so the first equation, 2x plus 3y equals 18, and the second equation is 4x minus 5y equals to -8. And here's the solution. Right, so before we want to draw the graph for 2x plus 3y equals 18, we have to form the table first. Right, so the x and the y value, let's choose a very simple value for x. Let's choose as 0. When x is 0, what will happen to the y? So look at this equation. This term is 0, it becomes 3y equals to 18. Hence y will be 18 divided by 3, which is 6. Alright, now we can also choose for the y value, right? Choose a very simple value when y is 0. So what will happen to x equals to 18? Then x will be 18 divided by 2, which is 9. Alright, so next just choose any values, right? Very simple value. When I say simple value, means that it's easy for us to calculate. So let's say x is 6, right? Then 2 times 6 is 12. 18 minus 12 equals 3y. Then y will be 6 over 3, which is 2. Okay, so this is the table for the first equation. So repeat the same process for the second equation. 4x minus 5y equals -8. Alright, so again, draw the table for the x and the y value. Let's choose y equals to 0. Right, so what will happen? It will become 4x equals to -8. Then x will be -8 divided by 4, which is -2. Alright, so then the next value, I might not choose x equal to 0 for this case, because when I look at this equation, when x equals to 0, right, we have negative 5y equals to negative 8 or 5y equals to 8. Then the value of y is not an integer, so I might not choose the y value. I might not let x to be 0. So let's say I let x to be 4 here. What will happen? So 4 times 4 is 8, right? Then it becomes negative 5y equals to negative 16. So y will be negative 16 over negative 5, which is 4.8. Right, yeah, you might say this is not that perfect because this is not a whole number, but it's still fine, right? So let's choose another value when y equals to 8. So what happened? So this one will be 8 times 5, negative, it is 40, right? And the corresponding value for the x will be 8. Okay, so this is the table for the second equation. So once we have these two tables, we can start to plot the graph. Okay, so let's draw the x-axis and we choose the scale, right? We look at here, the smallest value of x is negative 2 and largest is 9 here. So maybe I want to draw the graph to the x-axis, right, covering from negative 2 to 9 or 10. Okay, so from here I will choose the scale for the x-axis, right, with 1 unit is to 1 cm is to 1 unit, right? We start with negative 2 here because I want to cover negative 2 here, and all the way to 9 because over here we have 9 here, right? So similarly for the y-axis, when I look at the value here, covering the smallest is 0, the largest is 8. Okay, maybe I'll choose covering from start from 0 all the way to 8 or 9, right? That means 1 cm is to 1 unit here. Okay, so after that, I can start to plot the graph. The first point here, 0, 6 is here. Second point, 9, 0. And the third point, 6, 2. Then take a ruler, join these 3 points together to form the graph of the first equation, which is 2y plus 3x equals to 18. Okay, repeat the same process for the second graph, right? The first point is negative 2, 0. Followed by 4.8. The next point 8. Okay, again take a ruler, join these 3 points together with a straight line, and this straight line is the graph of the second equation, 4x minus 5y equals to negative 8. And from here you can notice that these two lines intersect at one point here, and the coordinates of this point will be 3, 4. Okay, so this is the solution of these two equations. So from the graph, right, the solution is x is 3 for this value and y is 4 for this value. Okay, so this is the graphical method to solve simultaneous equation, and for this case it is the first possible result where we have one common solution here. Alright, now we look at example 2 where this is the second possible result that we get. So solve the simultaneous equation using graphical method. So the first equation is 5x plus 4y equals to 20. 5x plus 4y equals to 32. Alright, so solution is we have to plot the graphs for these two equations. Alright, so we repeat the same process. Okay, we have to build a table first before to draw the graph. So for the first x and y, let's choose x is 0. Then we calculate the corresponding value of y. And for this case, it is 5. So now I choose y equal to 0. And the x value will be 4. And I will choose y equals to 3. And x will be 1.6. Okay, so again, this is not very perfect value, but it's fine. As long as we can plot the graph easily on the graph. Okay, then let's see how later we want to plot a graph. Okay, so repeat the same process for the second equation. 5x plus 4y equals to 32, right? And build a table for the x and y value. Let's choose x is 0, and then the y value will be 8. When y equals to 0, the x is 6.4. Okay, again, this is just a decimal number. Okay, it's still fine. Let's see how if we can plot the graph. Then when y is 3 and x is 4. Alright, so we have these two tables, and let's start to plot a graph. Okay, so for the x-axis, okay, again I want to see the smallest value is 0 and the largest value is 6.4 here, right? So maybe you can choose a similar scale from the previous example. 1 unit is to 1 cm is to 1 unit. Okay, so similarly for the y-axis, right, we want to cover from the smallest value is 0 and the largest value is 8. So it's very similar scale for the previous example as well. 1 cm is to 1 unit. Okay, so now let's start to plot the graph. The first point is 0, 5. Okay, second point is 4, 0. The next point is 1.6, 3. Okay, take a ruler, join these 3 points together with a straight line. Okay, as you can see, even if it's a decimal number, it is just perfectly lying on this straight line. Okay, so this equation is 5x plus 4y equals to 20. Alright, repeat the same process for the second equation. The first point is 0, 8, which is here. Then 6.4, 0, which is here, right? And 4, 3, which is this point. Okay, and take a ruler, draw a straight line. Okay, and this straight line is the graph of 5x plus 4y equals to 32. Okay, and as you can see from this graph, right, because we want to solve simultaneous equation, we can see that both lines are parallel. They don't intersect at one point. Okay, so which means that there is no solution for this case. Alright, now we look at example 3, which is infinite solution case. Okay, same question, solve the simultaneous equations using graphical method. So the first equation is 3x plus 4y equals to 24, 6x plus 8y equals to 48. Okay, solution here, right? Again, when to plot the graph, we have to build a table here. For the x and the y value, again choose the easy value, x is 0, then calculate the value of y, which is 6 here, and then I choose y equal to 0, then x is 8. Right, then I choose when y is 3, then the x value will be 4. Okay, repeat the same process for the second equation, 6x plus 8y equals to 24. Then we build the table, x and y. We choose x value to be 0, then calculate the corresponding value of y, which is 6. And then followed by, when I choose y equal to 0, calculate the value of x, which is 8. And then I choose y equal to 3, and the x value is 4. Again, as you can see, now we compare, right? For this case, these two tables is exactly, they are identical, right? The same value, no difference at all. So what happens if I want to plot the graph? Okay, so again, the x-axis, the scale is 1 cm to 1 unit, so that I can cover the smallest value is 0 and the largest value 8, right? So 0 to 8 somewhere here. Okay, so now for the y-axis, right, I will choose covering from 0 to 6, right? So 1 unit is to 1 cm is to 1 unit here. Then I can start to plot one by one. For both, since they are identical, right, it's the same thing, right? The first point is 0, 6. Second point 8, 0. The third point 4, 3. So after that, take a ruler, join them together. So this straight line represents these two equations. The first equation, 3x plus 4y equals to 24, and the second equation is 6x plus 8y equals 48. Alright, so now you can see that both graphs overlap with each other. Remember, when we want to find a solution, these two graphs, right, must intersect at one point, right, must have intersection point. But for this case, any point on the line will be the solution. So there are infinite solutions for this example 3. Alright, after discussing all the 3 possible results that we might get in solving simultaneous equations in 2 variables, let's make a summary here. So how to tell if it is the first case, only one solution? Okay, now let's look at the example 1 again, right? We have the 2 equations. The first equation is 2x plus 3y equals to 18, and the next equation is 4x minus 5y equals to negative 8. We compare these 2 equations. Look at the coefficients of the x. So the first one is 2, the second one is 4. And the coefficient of the y, the first is 3 and the second is negative 5. So from here we can see that both x and y terms have different coefficients. Then we look at the constant term. the first constant term is 18 and the second constant term is -8. From here, both equations have different constant terms as well. Okay, so if you see this type of equations, then most likely it is they have one solution. Okay, then how to tell if there is no solution? Right, let's look at example 2 here, right? The first equation is 5x plus 4y equals to 20, and the second equation is 5x plus 4y equals to 32. Let's compare the coefficient for the x, right? And for the y, we can see that both x and y terms have the same coefficients. And now we compare the constant terms. We can see that both equations have different constant terms. Okay, so from here, we know that y equals to mx plus c, right? Where you can, we learn from the coordinate geometry chapter. So let's rearrange the equation in this form. So for the first equation, we have y equals to -5 over 4x plus 5. And the second equation, y equals to -5 over 4x plus 8. As you can see here, the m value for these two equations are the same. Okay, so the m actually, it means the gradient of the graph. We can see that both equations have the same gradient. If you learn coordinate geometry chapter, when two equations have the same gradient, it means that they are parallel lines. Okay, so when they are parallel lines, then it is impossible for these two lines to intersect with each other, hence there is no solution. Okay, now how about infinite solutions? How can tell if the two equations are infinite solutions? Let's look at the example 3 again. The first equation is 3x plus 4y equals to 24, and the second equation is 6x plus 8y equals to 48. So for the second equation, let's divide by 2 for both sides and see what we get. We will get 3x plus 4y equals to 24. And you can see that both equations come from the same equation. They are exactly identical equation. So even if you want to plot the graph, we will get exactly the same linear graph for these two equations. Hence, they overlap with each other and they have infinite solutions because every point on the line will be the solutions for these two equations. Okay, I hope you understand, right? How can you tell if there is one solution, no solution, and infinite solutions? We have just learned the first method to solve simultaneous linear equation in two variables, which is the graphical method. Okay, however, the graphical method, we actually seldom use it because every time we want to solve the simultaneous equations, we have to draw graphs. Okay, so when we want to draw graphs, it will be very time consuming and it might be inaccurate when we want to plot the graph. All right, so that's why, right, we have another two methods. The second method is the substitution method, and the third method is the elimination method. So let's discuss the substitution method. We use the exactly same example again so that you can compare, right, the difference between these three methods. So for example 1, we want to solve the simultaneous equations. Now we want to use substitution method. So the first equation, 2x plus 3y equals to 18, and the second method is 4x minus 5y equals to -8. Alright, so here's the solution. So to solve with substitution method, there are a few steps that we want to follow. Right, the step 1 is we want to copy and number the equations. So what do I mean? So let's copy the first equation is 2x plus 3y equals to 18. Then and the second equation is 4x minus 5y equals to -8. I will label the first equation as number 1 and the second equation is equation number 2. Alright, so we want to number the equations so that we can refer the equations easily. So step number 2, we want to decide which term to be substituted. So let's say I want to substitute x first. Alright, so if I have decided to substitute x, then step number 3, I want to choose one equation from any of these two equations and then make x the subject. So for this case, I want to choose equation number 2. Alright, so if I choose equation number 2, Then this is the second equation, 4x minus 5y equals to negative 8. So when I make x a subject, the equation becomes x equals to 5 over 4y minus 2. Next, step number 4, number this new equation as equation 3. So I will label this as equation number 3. Step number 4, I want to substitute and solve for the x and the y. So for this case, I will substitute equation number 3 into equation number 1. Right, so one more time, right? So this is equation number 3, x equals to 5 over 4y minus 2. Then this is equation number 1. So just substitute this whole thing into x here, right? So now let's see. This is the first equation, 2x plus 3y equals 18. So substitute x is 5 over 4y minus 2, and this is the equation that we get. Next step, expand the bracket. I will get 5 over 2y minus 4 plus 3y equals 18. Right, simplify. 11 over 2y equals to 22. Then y will be 22 times 2 divided by 11, which is 4 here. Okay, so I found the value of y. Then I substitute this y equals 4 into the equation number 3. Okay, because equation number 3, x is a subject already. Substitute inside here. 5 over 4, the y is 4. Then minus 2. Okay, then calculate the value for x is 3. Hence, the x equals to 3 and the y equals to 4. Okay, so you might ask me, can I substitute the y instead of x? The answer is yes, of course you can. So it doesn't matter whether you want to substitute x or y. So just make sure that the next step, right, you just make, let's say you substitute y, you make the y the subject. Okay, for this case, I personally choose to substitute x because as you look at this equation, right, when I want to make x the subject, right, it will be a positive gradient here. Okay, so I would prefer to have positive values so that the calculation is easier and I will tend to make less mistakes. Alright, but again, there's nothing wrong if you want to substitute the y and then you make y the subject, then substitute into maybe equation number 1. Okay, so it's up to you to substitute x or y. Okay, now look at example 2, which is for the second possible result, which is no solution. Solve simultaneous equations using substitution method here. Right, the first equation is 5x plus 4y equals to 20. Second is 5x plus 4y equals to 32. Okay, so solution, 5x plus 4y equals to 20 and 5x plus 4y equals to 32. We copy these two equations and then we number the equations. So this is the equation 1 and this is equation 2. Then I will say from equation 1, I make, let's say I choose y to be eliminated, then I'll make y the subject, hence y equals to negative 5 over 4x plus 5. Then I name this as equation number 3. The next step, I will substitute equation 3 into equation 1. So this is equation 1, 5x plus 4y equals to 20. Then I substitute the y to be negative 5 over 4x plus 5. Expand the bracket, I will have 5x minus 5x plus 20 equals to 20. And from here, as you can see, 5x minus 5x, they cancel out each other. I only left with 20 equals to 20. So this equation becomes very weird, right? So because there is no solution for this case. As you can see, both x and y are eliminated. Hence, there is no solution. And now, let's look at example 3 where they are infinite solutions and see what happens if I use substitution method, right, to find the answer. Okay, so solve simultaneous equation using the substitution method. Again, the equation is 3x plus 4y equals to 12, 6x plus 8y equals to 24. Alright, so solution, first equation, second equation, number them, equation 1, equation number 2. And I will say from equation 1, let's say I have decided to eliminate the y. So for equation 1, I make y the subject. I have negative 3 over 4x plus 3. Then I name this as equation number 3. After that, I substitute equation 3 into equation 2. Then this is equation 2, 6x plus 8y equals to 24. So substitute y to be negative 3 over 4x plus 3. Expand the bracket, I have 6x minus 6x plus 24 equals to 24. And as you can see here, it becomes 24 equals to 24 here. So again, both x and y are eliminated. Alright, so and there is no I can say that there is no single common solution. So why do I want to say so, right? Because as you can see, compare example 2 and example 3 here, right? It is very difficult to tell if it is no solution or it has unlimited solution. So I can only say that we don't have any single solution for here. Okay, now let's discuss the third method to solve simultaneous equations. So the third method is called the elimination method. Okay, so we'll use the same example here, example 1. So solve simultaneous equations using elimination method. So first equation 2x plus 3y equals to 18. Second equation 4x minus 5y equals to negative 8. And here's the solution. So we have a few steps to follow. Step 1, we copy and number the equations again, right? So this is the first equation, this is the second equation. I would say this is equation number 1 and this is equation number 2. Okay, now the next step, step number 2, right? We want to decide which term to be eliminated. Okay, so for this case, I want to eliminate x. So why is it so I don't choose y, right? Of course, there's nothing wrong if you want to choose y, but I will look at these two equations. I can see that the coefficient of the x for these two cases, right? This is the multiple of the 2 here, right? So they are multiples of 2, so it is easier to eliminate x instead of eliminate y. Like as you can see, right, 3 and negative 5, they are not multiple, maybe 3 or 5, right? So I would not choose it. If you want, you can choose. There's nothing wrong with that. Okay, but ultimately we get the same answer. Okay, now move on to step number 3. We want to make the coefficient of x for both equations to be the same. So what I have to do is, for equation number 1, I multiply by 2. And I will, this equation number 1, 2x plus 3y equals to 18. So when I multiply by 2 for both sides, I will have 4x plus 6y equals to 36. Then I will number this new equation as equation number 3. So this is equation number 3. After that, I want to eliminate x by subtraction or addition. So for this case, right, the equation number 3, the coefficient of x is 4. Okay, and similarly, for equation number 2, right, the coefficient of x is positive 4 as well. Hence, I will say equation number 3 minus equation number 2. I will have 4x plus 6y. So this is the third equation, and this is the second equation, right? So it becomes 4x plus 6y minus bracket 4x minus 5y equals to 36 minus bracket negative 8. Okay, expand the bracket. We get 4x plus 6y minus 4x plus 5y equals to 36 plus 8. As you can see, 4x minus 4x, they will cancel out or eliminate the x. Only for the y, 6y plus 5y, I get 11y. 36 plus 8, I get 44. Hence, y will be 4. So once I get the value of y, I just need to substitute this value into any of the equation. So let's choose equation number 1. I will choose equation number 1 because the values are smaller, so I can calculate easier. So 2x plus 3 times 4 equals to 18. 2x is 6, hence x is 3. Therefore, the solution is x equals to 3 and y equals to 4. And now let's look at example 2 for the no solution case. So same question with using elimination method, same equation, 5x plus 4y equals to 20, 5x plus 4y equals to 32. So solution, okay, so copy the equation and number the equation. So this is equation number 1, this is equation number 2. Then from here, I can see that the coefficients for the x and y actually are the same. So what happened is equation 2 minus equation 1, I will get 5x plus 4y minus bracket 5x plus 4y equals 32 minus 20, which is 0 equals to 2. So this equation looks very, very weird. How can be 0 equals to 12, right? So this means both x and y are eliminated, hence there is no solution for this case. Right, example 3. So this is for the unlimited solution case. So solve simultaneous equation with elimination method. So this is the first and second equation. So the solution, again, the same steps. These two. So this is the first equation and this is the second equation. and I want to say that, let's say equation 2 divided by equation divided by 2 for both sides, so that I can make them to have the same coefficient, right? So 6x plus 8y equals to 24 divided by 2 for both sides. I get 3x plus 4y equals to 12. Then I name this as equation number 3. So equation 3 minus equation 1. So this is what I get, 3x plus 4y minus bracket 3x plus 4y equals to 12 minus 12. And I will get 0 equals to 0. Okay, so I think this is more easier to understand, because since both are the same equation, then when they minus each other, we will get 0. Okay, so both x and y are eliminated, which means that there is no single common solution, or maybe for elimination method, it is easier to tell if it is an unlimited solution, because both sides are 0. Hence, it has unlimited solution. Now, let's have more practice so that you are exposed to more different types of questions and different types of equations. Okay, example 4. Solve the following simultaneous equations using substitution method. A. X plus 2y equals to 14. 3x minus y equals to 21. B. X over 2 plus y over 3 equals 8. 3x over 2 minus 5y over 6 equals 13. C. 0.3x plus 1.7 y equals 4.9. 1.4x minus 3.5y equals 0. D. 2x plus 3 bracket y plus 4 equals 7. 5 bracket 2x plus y plus 2 bracket x minus 1 equals 33. Okay, so as you can see from this example, these 4 examples here, right, they have a little bit they are a little bit different. So this is the A is a usual question, right? Everything is whole number. So coefficient is 1, 2, 14, 3, -1, and 21. For the B, as you can see here, it involves fraction. For C, it involves decimals. And for D, you have to simplify first before you want to solve these two equations. Alright, so now let's look at the solution here. For A, you can do it as usual, since it asks us to use substitution method. So we use substitution method. X plus 2y equals 14. This is the first equation, and this is the second equation, right? So I want to eliminate, let's say for this case, I want to eliminate y. Then from equation number 2, I make y the subject. So it becomes y equals 3x minus 21. I name this as equation number 3. Then I substitute this equation into equation 1. Substitute equation 3 into equation 1. So substitute the y to be this whole thing. So I will get x plus 2 bracket 3x minus 21 equals to 14. Expand the bracket. I have x plus 6x minus 42 equals to 14. So solve this equation. 7x equals 56. Hence x is 8. After that, substitute x equals 8 into the third equation here. So x is 8. 3 times 8 is then minus 21. I have 3 here. Hence, the solution is x equals 8 and y equals to 3. So for B, x over 2 plus y over 3 equals 8. And the second equation, 3x over 2 minus 5y over 6 equals to 13. So first equation, and this is the second equation. Alright, so for the equation for the case involve fractions, what I want to do is I want to make it to be the whole number, right? So the LCM of 2 and 3 is 6. So for the first equation, I multiply by 6 for both sides. So this is what I get. I will have 3x plus 2y equals to 48. As you can see here, there is no fraction. So from equation with fractions, it becomes equation with whole numbers. Okay, so that later on when we want to calculate, it's much easier to calculate. So similarly for the second equation, right, 2 and 6. Yeah, okay, before that, for this equation, I make y to be negative 3 over 2, x equals plus 24. Make it to subject because I want to eliminate the y. Alright, so then I label this as equation number 3. For the equation number 2 here, right, 2 and 6, the LCM is 6. Multiply 6 for both sides. I will get 9x minus 5y equals to 78. Okay, again you can see that there is fraction for the second equation, no fraction, everything is whole number in this is the fourth equation. Okay, so after that substitute from equation number 3, okay, into equation number 4 here. So when you see the y, just put it as this whole thing, right? 9x minus 5 bracket negative 3 over 2x plus 24 equals to 78. Then the next step, expand the bracket. So you get 9x plus 15 over 2x minus 120 equals to 78. So solve, now everything is x, there is no y. So solve this equation and the value for x will be 12. So after that, substitute this into the third equation. So y will be negative 3 over 2 times 12 plus 24 and the value is 6. Hence, the solution for b will be x is equals to 12 and y equals 6. So for C, this is equation number 1 and this is equation number 2. Alright, so these two equations, it looks like a very difficult equation because it involves decimal. But when we want to solve it, we just treat it as numbers, right? Those steps have no difference with how you solve for A and B. Okay, so now from number 2, I want to make x the subject. So it's 1.4x equals 3.5y. Hence x will be 2.51. Okay, so as you can see here, just treat it as usual, right? It's just involve decimal number here. So I label this as equation number 3. So after that, I substitute this into substitute equal 3 into equation 1. So this is the x here, 0.3 times 2.5y plus 1.7y equals to 4.9. As you can see here, now x is replaced with 2.5y. Okay, then simplify 2.45y equals to 4.9 and solve it y equals to 2. Then substitute y equals to 2 into the third equation. X will be 2.5 times 2 and the value of x will be 5. Hence, the solution is x equals to 5, y equals to 2. Okay, then for D, 2x plus 3 bracket y plus 4 equals to 7 and 5 bracket 2x plus y plus 2 bracket x minus 1 equals to 33. So this is my first equation, this is my second equation. From the first equation, I have to expand the bracket and simplify. So I will have 2x plus 3y plus 12 equals to 7, hence 2x plus 3y equals to negative 5. Then from here, I make y the subject, y equals to negative 2 over 3x minus 5 over 3. I label this as equation number 3. So do the same thing for equation number 2. Expand the bracket, I have 10x plus 5y equals 2x minus 2 equals to 33. Simplify, I have 12x plus 5y equals to 35. I label this as equation number 4. So what's the next step? The next step is I substitute equation 3 into equation 4. So when I see the y here, I just substitute everything here into this equation. So it becomes 12x plus 5 bracket negative 2 over 3x minus 5 over 3 equals to 35. Then expand the bracket, 12x minus 10 over 3x minus 25 over 3 equals to 35. Okay, so further simplify, 26 over 3x equals 130 over 3. So the 3 here can cancel and x will be 130 divided by 26, which is 5. Okay, so once I find the x value, I can solve for the y value, substitute the x to be 5. Equation becomes negative 2 over 3 times 5 minus 5 over 3. So calculate everything, I will get negative 5 for y. Hence, the solution for D will be x equals 5 and y equals to negative 5. Now, in example 5, I use exactly the same equations as in example 4, but for this case, I want to use elimination method. Okay, so I want to use the same equations so that after this, you can compare all these different methods, and then you can decide yourself, right, which methods do you prefer to use. Because in exams, usually they don't ask you to use any specific methods unless otherwise stated. So you are free to use any of the method. Okay, to be honest, for me, I would prefer to use elimination method because the steps are shorter. Okay, and I also tend to make less mistakes. So I prefer elimination method. Of course, there's nothing wrong if you tell me that if you prefer to use substitution method. Okay, so exactly the same thing, equation, right? Let's see how we can use elimination method, right, to solve this equation. So solution for A is just a regular example here, right? So x plus 2y equals to 14, 3x minus y equals to 21. So this equation 1, equation number 2, right? I want to eliminate, let's say for this case, I want to eliminate with the y, okay? Then I have to make them to have the same coefficient. So what I have to do is, for equation number 2, I multiply with 2. So now I will have 6x minus 2y equals to 42. Okay, as you can compare, they have the same coefficient. The only difference is one is plus, one is minus, but it's still fine. Okay, so this equation labeled as equation number 3. So why I say it is still fine, so I can say instead of minus equation 1 minus equation 3, I put a plus here. Okay, we can do that as well. Okay, so now x plus 6x, I have 7x, then 2y minus 2y, they will eliminate each other. Okay, now the right side 14 plus 42 is 56. Okay, then x will be 8. And from equation number 2, right, I substitute x with 8 into the equation. So 3 times 8 minus y equals to 21. Then y will be 24 minus 21, which is 3. Hence, the solution is x equals to 8 and y equals to 3. Now for B, x over 2 plus y over 3 equals to 8, and 3x over 2 minus 5y over 6 equals to 13. So first equation, second equation. So again, this example involves fractions. So what we have to do is, let's say equation number 1, I multiply by 6. Okay, so that I make everything to be whole number. Okay, and then this is equation number 3. I think this is very similar with the substitution method. So for number C, right, for number equation number 2, I multiply by 2. I have 3x minus 5y over 3 equals to 26. This is equation number 4. So as you can see here, the coefficient for the x is the same. Then I can say that I take equation 3 minus equation 4. Okay, so I have 3x minus 3x will cancel each other. So now 2y minus negative 5 over 3y equals to 48 minus 26. Okay, be careful with the minus sign here. Okay, so some students, they will mix up this one, right? Then the calculation will be wrong. Okay, so when I calculate, it becomes 2y plus 5 over 3y, which is 11 over 3y. The right hand side, 48 minus 26 is 22. So solve this, y will be equals to 6. Then substitute this y equal to 6 into equation number 1. Maybe this one, right? So x over 2 plus 6 over 3 equals to 8. So x over 2 will be 6, hence x will be 12. Then the solution for this equation, this example will be x equals to 12 and y equals to 6. So for C, let's say this is equation 1, this is equation 2. So C will be a little bit trickier because it is decimals. So let's say, right, I want to eliminate x. So I want to eliminate x, which means that I need to make them to have the same coefficient. So what I have to do is, for the equation 1, I divide by 0.3 so that this will be cancelled. And to make it to be 1.4, then I multiply with 1.4. So hence, for equation 1, I multiply 1.4 over 0.3. So let's see what happened, right? It becomes 0.3 times 1.4 over 0.3 x plus 1.7, so which is here, right, times 1.4 over 0.3 y, and 4.9 times 1.4 over 0.3. Okay, then simplify everything here, right? I get 1.4x plus 119 over 15y equals 343 over 15. Okay, so all this, what you have to do is just press calculator, right? Calculator will tell you the values. Okay, and it is equation number 3. Of course, you might tell me it looks very complicated with the fractions and the number is very big. Okay, yes, it is, but you have to be careful. Okay, and then I can say that I take equation number 3 minus with equation number 2 here, right? And this is what I get: 1.4 minus 1.4x here, right? Cancel each other. 119 over 15 minus here, right? Negative 3.5 y, so which is this one. okay, equals to 343 over 15. So nothing here, we don't have to minus anything here. Okay, so again, minus and minus will give you positive. Be careful with the sign here, right? You have 343 over 30, y equals to 343 over 15. Hence, y will be 2 here. Okay, and then from 1, substitute it into the first equation, right? Y equals to 2 here becomes 0.3x plus 1.7 times 2 equals 4.9. Solve this equation, x will be 4.9 minus 1.7 times 2 over 0.3, which is 5. Okay, hence the solution will be x is equals to 5 and y equals to 2. Alright, so yeah, I do agree, right? It is quite complicated, and this also tells you that when it comes to this type of example where it involves decimals, elimination method is more tedious to do. Okay, then maybe you can, as you can compare with the substitution method. Substitution method, when it comes to this kind of example, right, the solution to solve it is much easier. So for D, this is the first equation and this is the second equation. So the first step is very similar with the previous method, the substitution method. So we have to expand the bracket, simplify, and label this as equation number 3. Similar for equation number 2, right? Expand the bracket, simplify, and we label this as equation number 4. And now you can see that it is just follow the standard procedure. Okay, everything is a whole number, right? To find the elimination method. So maybe for equation number 3 here, I multiply with 6 so that the coefficient of x will be the same. I will get 12x plus 18y equals to negative 30. Label this as equation 5. Then after that, equation 5 minus equation 4 here, right? So that 12x minus 12x cancel each other. 18y minus 5y, right? I will get this one, negative 30 minus 35. So we get this one, right? Which means it is 13y equals to negative 65. Solve it, y equals to negative 5. Then after that, substitute this into equation number 3, right? Maybe here. Okay, I will choose this because I can see that the values are very small, so calculation is easier. Then 2x plus 3 times negative 5 equals to negative 5. Hence, 2x is 10 and x equals to 5, right? So this is the solution. X is 5 and y is negative 5. Now we come to the last part of this chapter, word problems involving simultaneous equations. So there are 4 steps to follow to solve word problems involving simultaneous equation. So step number 1, you have to read the questions carefully and then identify the 2 unknown quantities that you need to find. Step number 2, use letters. Usually we use x and y to represent the unknown quantities. We form 2 linear equations connecting the relationship between the unknowns based on the information given by the question. Step number 3, then we solve the simultaneous equations. And step number 4, you can check if the solution makes sense. Right? So usually, if the solution makes sense, then most of the time the answer is correct. Okay, if you find the solution does not make sense, most likely something is wrong in between the steps that you have written, so you have to check. So in summary, what you have to do is read, form, solve, and check. So just follow these 4 simple steps for word problems. Now let's look at example 6. The total mass of 6 pencil cases and 5 staplers is 2.7 kilograms. The total mass of 4 pencil cases and 3 staplers is 1.7 kilograms. Find the mass of a pencil case and a stapler in grams. Here's a solution. So we let x to be the mass of a pencil case and y to be the mass of a stapler. So for the first sentence, 6 pencil cases and 5 staplers, we can write as 6x plus 5y. So it is 2.7 kilograms, then equals 2,700 grams. Okay, you can see I have changed the kilograms to grams because at the end my answer must be in grams. Okay, so I will change it first. I label this as first equation. Of course, you have to be careful here because the value is quite big, right? So you might tend to make mistakes. Then the next sentence, 4 pencil cases and 3 staplers. So it will be 4x plus 3y. It is 1.7 kilograms. So it is equals 1,700. I will label this as equation number 2. Okay, I will use elimination method to solve these two equations. So the first equation, I multiply by 3. I will get 18x plus 15y equals 8,100. I will label this as equation number 3. So similarly for equation number 2, I multiply by 5 and I will get 20x plus 15y equals 8,500. I will label this as equation number 4. Alright, so why I want to do this, you compare these two equations. Obviously, I want to eliminate the y. So what I have to do is, I will say equation 4 minus equation 3. So I will get 2x equals 400. Hence x equals 200. Then from equation number 2, I substitute x equals to 200 into the equation. It becomes 4 times 200 plus 3y equals 1,700. So 3y equals to 900 and then y equals 300. And now I can answer the question. The mass of a pencil case is 200 grams and the mass of a stapler is 300 grams. Try it yourself 6. At a cinema, the price of 6 adult tickets and 13 child tickets is $176. The price of 7 adult tickets and 8 child tickets is $148. Find the total price that Mr. Lingam needs to pay if he buys 12 adult tickets and 10 child tickets. You can pause the video and try to solve yourself. Alright, here's the solution. Now I let x to be the price of an adult ticket and y to be the price of a child ticket. So based on the sentence, 6 adult tickets and 13 child tickets, I can write it as 6x plus 13y, and it is equals $176, hence equals 176. I label this as equation number 1. And the next sentence, 7 adult tickets and 8 child tickets. So I will write 7x plus 8y is $148, hence equals 148. I will label this as equation number 2. Alright, now I want to solve simultaneous equation. Let's try this with substitution method. So I will say from equation number 1, I want to make y the subject. So the y will be equals negative 6 over 13x plus 176 over 13. I will label this as equation number 3. So from here, I will substitute equation number 3 into equation number 2. Hence, it becomes 7x plus 8 bracket negative 6 over 13x plus 176 over 13 equals 148. Then I expand the bracket. I will have 7x minus 48 over 13x plus 1,408 over 13 equals 148. Okay, simplify. I will have 43 over 13x equals 116 over 13. So x will be 12. So from equation number 1, I substitute x equals to 12 into equation number 1. I will have 6 times 12 plus 13y equals 176. So y will be 176 minus 6 times 12 over 13, which is 8. Okay, so now I can answer the question. So total Mr. Lingam need to pay will be 12 times 12 plus 10 times 8, which is $224. Example 7. 5 years ago, Mr. Tan's age was twice his son's age. In 8 years' time, the sum of his age and his son's age will be 107. Find Mr. Tan's age and his son's present age. Here's a solution. We let x to be the son's present age and y to be Mr. Tan's present age. So from the information given 5 years ago, then I can write x minus 5. So this is the son's age 5 years ago, and y minus 5. So this is Mr. Tan's age 5 years ago. So Mr. Tan's age is twice his son's age, then I can put equals 2 times x minus 5. Then I will put a bracket here so that the 2 multiply the whole thing x minus 5. Then from here, I expand the bracket and I simplify. And I will get 2x minus y equals 5. I will label this as equation number 1. Then the second sentence in 8 years time. So from here, I can say y plus 8. So this is Mr. Tan's age after 8 years, and x plus 8. So this is the son's age after 8 years. The sum of his age and the son's age is 107. So I will say y plus 8 plus x plus 8 will be 107. Okay, so from here I simplify y plus x plus 16 equals 107. So x plus y equals to 91. Then I will label this as equation number 2. Okay, so make sure we form these two equations correctly by reading the question carefully. And now we can solve simultaneous equation. Alright, so what I will do is I will say equation 1 plus equation 2 because I want to eliminate the y first. And the coefficient for the y in these two equations are the same. The only difference is the sign is different. One is positive, one is negative. That's why I add these two equations together. So I will have 3x equals to 96. Hence, x will be 32. After that, from equation number 2, I substitute x equal to 32. I will have 32 plus y equals 91. Then y will be 59. Alright, so what does it mean? It means that Mr. Tan's present age is 59 and his son's present age is 32. Try it yourself. 7. 4 years ago, Laura's age was 7 times as old as Macy's. In 6 years' time, she will be 3 times as old as Macy. Find Laura's and Macy's present ages. You can pause the video and try to solve it yourself. Alright, so here's the solution. First, we let x to be Macy's present age and y to be Laura's present age. Then, 4 years ago, Laura's age was 7 times as old as Macy's. We can form the equation to be y minus 4 equals 7 times bracket x minus 4. Then we expand the bracket for y. Y minus 4 equals 7x minus 28. So simplify. 24 equals 7x minus 2y, or rewrite again 7x minus y equals to 24. Then I label this as equation number 1. And then the second sentence, in 6 years' time, she will be 3 times as old as Macy. The equation becomes y plus 6 equals 3 times bracket x plus 6. Expand the bracket, we have y plus 6 equals 3x plus 18. Then rearrange the equation. Negative 3x plus y equals to 12. And I label this as equation number 2. Alright, now I can solve simultaneous equation. I will say equation 1 plus equation 2 so that I can eliminate y. So I will have 4x equals 36. Hence x equals to 9. After that, substitute this x to 9 into equation number 1. So it becomes 7 times 9 minus y equals to 24. Hence y will be 39. Okay, now I can answer the question. Laura's present age is 39 and Macy's present age is 9. Example 8. A 2-digit number is equal to 4 times the sum of its digit. The number formed by reversing its digit is 27 more than the original number. Find the original number. Here's the solution. So we let x to be the first digit, which is in the tens place, and y to be the second digit, which is in the ones place. Hence, the original number will be 10x plus y because x is in the tens place and y is in the ones place. Alright, so the information given, the two-digit number when we can write as 10x plus y equals, so put an equal sign here, 4 times the sum of its digit. Alright, so what does it mean? It means we can write as 4 bracket x plus y. Okay, so this is the equation we can form from the first sentence. Then we simplify, right? We have 10x plus y equals to 4x plus 4y. Rearrange this equation. 6x minus 3y equals to 0. Then we divide 3 for both sides. I have 2x minus y equals to 0. I will label this as equation number 1. Then I move on to the second sentence. The number formed by reversing its digit. Okay, so from here, when I reverse the digit, it becomes 10y plus x. Okay, it is 27 more than the original number. So what does it mean? It means it is equal the original number 10x plus y plus 27. Okay, so now I can simplify this equation. It becomes negative 9x plus 9y equals 27. Then I divide 9 for both sides. I have negative x plus y equals to 3. I will label this as equation number 2. Notice that equation number 1 and equation number 2, both the y term, we have the same coefficient. The only different thing is one is negative, one is positive. So what I can do is I will say equation 1 plus equation 2, I will have x equals to 3. Then immediately I can get the x value. After that, I will substitute x equal to 3 into equation number 1. So 2 times 3 minus y equal to 0. Hence, y will be equals to 6. And now, I can calculate the original number, right? Which is 3 times 10 with 30 plus 6 is 36. Try it yourself 8. In a fraction, when its numerator is increased by 4 and its denominator is increased by 6, its new fraction is equivalent to 2 over 3. When its numerator is doubled and 5 is added to its denominator, the fraction is equivalent to half. Find the original fraction. You can pause the video and try to solve yourself. Alright, here's the solution. So we let x to be the numerator and y to be the denominator. So the original fraction will be x over y. From the information given, numerator is increased by 4 and the denominator is increased by 6. We can write x plus 4 over 1, y plus 6. It is equivalent to 2 over 3. So it is equals to 2 over 3. After that, we cross multiply. We have 3 bracket x plus 4 equals to 2 bracket y plus 6. Expand, we have 3x plus 12 equals 2y plus 12. Rearrange this equation. We have 3x minus 2y equals to 0. Then I will label this as equation number 1. I move on to the second sentence. When the numerator is doubled and 5 is added to its denominator, I can write x 2x over y plus 5. And it is equivalent to half, hence equals 1 over 2. Cross multiply, I will have 4x equals y plus 5. Y equals 4x minus 5. I will label this as equation number 2. So I will substitute equation number 2 into equation number 1. I will get 3x minus 2 bracket 4x minus 5 equals 0. Expand the bracket, 3x minus 8x plus 10 equals to 0. So solve this equation, 5x equals to 10, hence x equals to 2. From equation number 2, we can find the value of y. Y equals to 4 times 2 minus 5, and the y value is 3. Hence, the original fraction equals 2 over 3.